In this example, there's nothing to do with the numerator. However, we will have to factor the denominator. There's no x to the first term, and 9 is a perfect square. So there we have it, using the difference of squares formula. And so we can't have the denominator equal to 0. X plus 3 will not equal 0, and x minus 3 will not equal 0. So x is not equal to positive or negative 3. Put that x bar for x is a real number such that x is not equal to positive or negative 3, and the curly Q braces around it, and then you have put it in set builder notation. Replace that not equal with equal, and you have the equation of, or actually equations of, two vertical asymptotes. I want you to notice that the multiplicity of the things that make the denominator 0, those are both to the first power. And so we will see a change in signs to either side of each asymptote. Since the degree of the numerator is 0, it's a constant term, and the degree of the denominator is 2, the equation of the horizontal asymptote will be y equals 0. There's also going to be no x-intercepts because we cannot make the numerator equal to 0. It's always going to be 2. Furthermore, that horizontal asymptote, y equals 0, will not be crossed, because if we try to solve this, we will get 0 equals 2, which is an untrue statement. So the horizontal asymptote is not crossed. The only special values of x that we found are negative 3 and positive 3. When we put in a 4 or a negative 4, squaring that would give us 16, and 16 minus 9 is 7. So there's 2 points. We know what the special values, that we've got the vertical asymptotes, the function is undefined there. And when we put in 0, 0 squared is 0, and 0 minus 9 is negative 9. So we've got negative 2/9. 2/7 is about 0.28, or if you only go to the nearest tenth, around 0.3. And negative 2/9 would be negative 0.2 repeating. So if you round to the nearest tenth, negative 0.2. And one more thing before I plot those points is that after we factored, we could only factor the denominator. We don't get any reducing from numerator to denominator, no common factors between the two. And so there are no holes in this graph either. So I'm plotting 3 points, negative 4, 2/7, 0, negative 2/9, and 4, 2/7. And that might seem to not give a lot of information, but when we include the vertical asymptotes and the horizontal asymptote, keeping in mind that we would see a change in signs to the left and to the right of the vertical asymptotes, then since this is positive, we should expect to see negatives over here. And then over here, since this is positive, we should expect to see negatives over here. We're probably going to see something like this on the outside, and inside something like this. Notice that we're not crossing the horizontal asymptote of y equals 0. And when we go to the far left and the far right, y values are getting closer to 0. Looks like from the positive side there.